Hello, a very good morning to all. I am Mr. S.S. Sazni from Department of Mechanical Engineering, Sharad Institute of Technology Polytechnic, and I am teaching the subject Thermal Engineering. And now we have already studied the first two chapters from this subject, that is Fundamentals of Thermodynamics, as well as the second chapter, that is Ideal Gases and their process. So today we are going to start with the third chapter, which is nothing but steam and steam boilers. So this chapter is theoretically very much lengthy, as well as this chapter will also have certain numericals. So we will also try to cover maximum numericals from this chapter. Now if we speak about this third chapter, that is steam and steam boiler, then as we know that the thermal power plant is the primarily used source of energy, and for understanding of thermal power plant we must first understand the process of steam formation. The process of steam formation is required to be studied in detail, and the steam boiler is the important component of steam power plant. So in this chapter we will see all the details regarding the steam as well as steam boiler. So first we will start with details regarding the steam and what are its several properties. Before starting with the actual points from this chapter, let's see what is the course outcome covered from this chapter. So at the end of this chapter, the students will be able to use relevant steam boilers. That is, we are going to see what are the various types of steam boilers, such as a water tube or fire tube boiler, what are the differences between these types of boiler, and which type of boiler can be used according to the applications. So we will see that in the further points. Right now we will start with the steam part. So let's see what is the steam. As you already have seen how the steam look like, so now we will see what is the steam. So steam is the vapor of water and is invisible when pure and dry. It is used as a working substance in steam engines, boilers and turbines. Also in the background you can see how the steam look like. So we are going to study how the formation or generation of steam takes place at constant pressure, and also we will need this point in further chapters also, because we are going to study how the steam forms in this chapter, and in the later chapter we can also see how this steam is utilized for the generation of energy, that is in case of steam turbines. So we are using these steam turbines for the generation of energy, and we are going to study this in the next chapter, that is fourth chapter. Right now we will first see how the formation or generation of steam takes place, and for this purpose we should know what is the meaning of sensible heat and latent heat, because these two terms are going to come when we are studying the formation of steam. So let's see what is the difference or what is the meaning of sensible heat and latent heat. So these are the types of heat. That is sensible heat. It is nothing but the temperature or heat which can be sensed. In other words, we can say that when an object is heated, its temperature rises as heat is added, and the increase in heat is called as sensible heat. Similarly, when heat is removed from an object, its temperature will fall, and the removed heat is also called as sensible heat. The heat that causes a change in temperature in an object is called as sensible heat. So we are having here definition regarding the sensible heat, and in simple language you can just remember that sensible heat is nothing but the change in temperature. Either it can be the rise in temperature or fall in temperature. So this change is nothing but we call it as sensible heat. And when we are talking about sensible heat, then we should first remember that in case of sensible heat, there will be no change in phase of the system. Now if we talk about the latent heat, then this type of heat is related with change in phase. That is, for example, if we consider solid phase, then with the addition of latent heat, this solid state is converted into liquid state. Or if we consider the liquid state, then it will be converted into gaseous state. So in this way, whenever there is a change in phase due to addition of heat, then we call it as latent heat. So if we look at the definition, then the heat that causes does not affect the temperature of the system, but it will result in change of phase of the system, then we call it as latent heat. And we can also see here example, that is water remains at 100 degrees Celsius while boiling, and if we are adding some extra heat when the water reaches at 100 degrees Celsius, then whatever the amount of heat that we are adding, that will be utilized to keep the water boiling. So the water which is at liquid state, it will start to convert into gaseous state, that is it will be converted into vapor. So after 100 degrees Celsius, whatever the heat we are adding to the water, that will not increase the temperature of the water, but instead it will start to convert the liquid state into gaseous state. And thus we say that the heat that causes a change of state with no change in temperature, it is nothing but latent heat. So I now hope that you have understood the difference between sensible heat and latent heat. So we can summarize this as follows, that is, sensible heat, it is the heat where there will be no change in phase, but there will be increase in temperature. Whereas in case of latent heat, there will be no increase in temperature, but there is going to be a definite change in the state of the system. So this was all about the types of heat, that is sensible heat and latent heat. Now in the next slide, we will see how the formation or generation of steam takes place at constant pressure. So here we are having the diagram where on the x-axis we are having heat supplied, that is we are having enthalpy, whereas on y-axis we are having temperature. So if we look at this diagram, then we will understand how the formation or generation of steam takes place at constant pressure by dividing this diagram into several stages. So first of all, we will consider the formation of steam from ice, which is at minus 10 degrees Celsius when atmospheric pressure is 1.013 bar. So this conversion of ice into steam, it can be explained with the help of this given diagram. So the stages of heat addition for 1 kg can be explained as follows. So if we consider the first part of this diagram, which is indicated by the region or line A to B, this line or region, it usually represents the heat of ice from minus 10 degrees Celsius to the melting temperature of ice, that is 0 degrees Celsius. So during this stage, heat is added to the ice at minus 10 degrees Celsius to 0 degrees Celsius, which is the melting point of ice. During this addition of heat, the temperature of ice will increase, and we can sense the temperature in thermometer. So during this stage, whatever there is change in heat, we call it as sensible heat. So you have already studied this concept of sensible heat and latent heat, and that was the reason why I have taken those points in the earlier slide. So during this heat addition, that is the stage A to B, only solid phase will exist, that is nothing but ice. After this first stage, the next stage of heat addition is represented by line B to C. So here it is by mistakenly printed as G. So you just consider that as C. So this region B to C, it represents the latent heat of fusion of ice. So at point B, ice is at its saturation state, and on further addition of heat, there will be no increase in temperature. But if we are adding extra amount of heat, then due to this heat, the ice will start to convert its phase. That is, it will be get converted into water, or we can simply say that the transformation of phase will take place. And at point C, all the ice which was available at point B, it will be totally converted into water. That is at point C. Thus, in this region, solid as well as liquid phase exist, and the heat supplied is called as latent heat, as it cannot be sensed by thermometer. It is very interesting to know that the actual meaning of latent is nothing but hidden. So whenever we are talking about the latent heat, then you should know that we can never measure the latent heat with the help of thermometer. Okay, after this stage, the next stage of heat addition is represented by this line, that is C to D, and this region is called as sensible heating of water from 0 degree Celsius to saturation temperature. In this region, the water at 0 degree Celsius is heated to 100 degree Celsius. So you can see that the graph has been drastically raised in upward direction. The boiling point of water, or the saturation temperature, is 1.0325 bar, that is constant pressure. In this region, whatever there is a change in temperature, we can measure it with the help of thermometer, and therefore it is called as a sensible heat of water. It is also important to note that during this stage, that is C to D, there will be no any change in phase. Okay, that's the reason why we are calling it as a sensible heat in this stage. So in this region, only liquid phase will exist. After this stage, we can see the next stage, which is represented by the line D to E. So this region is called as latent heat of vaporization of water, and at point D, water is at saturation state, and with further addition of heat, there will be no any increase in temperature, but instead whatever the heat is provided, it will be utilized to convert or to change the phase of the system. That is, whatever the liquid content we are having, that will be converted into gaseous state. So we call it as there will be change in phase, and whenever there is change in phase, we know that it is concerned with the latent heat. So since here we are trying to convert water into gaseous state, that is nothing but steam, so we call it as vaporization, that is a latent heat of vaporization of water, which means that we are adding the latent heat into this system so that the liquid is converted into gaseous state. Thus, the latent heat of vaporization of water, we can define it as the amount of heat added at constant temperature to convert 1 kg of water into steam. And usually it is denoted by small hfg. So we will see that notations for these terms while solving the numericals. Then again, after this stage, we are having one more last stage, which is represented by line E to F, and this is called as superheating of steam. At point E, steam is present in its dry saturated state. It does not contain any moisture, as all the liquid is converted into steam. So if further heat is added to the steam, then there will be increase in temperature of the steam, and this process is called as superheating. So in short, we can say that superheating is defined as heating of steam above its saturation temperature. So you should know now that at point E, we are having the steam at saturation temperature. So after point E, whatever the amount of heat we are adding to the steam, it will cause a rise in temperature of this steam. So we call it as superheated steam, and such type of steam is very useful for power generation, which we are going to study in the 4th chapter. So this was all about how the formation of steam takes place at constant pressure. Now I hope that you have understood that how the formation or generation of this steam take place. And also this is very important question because it can be asked in the MSBTE paper. So just you can take help of this diagram, and accordingly by observing all these regions, that is stages of heat addition, you can write the theoretical points from this diagram only. Now let's move to the next point. In a few of the MSBT papers, we are having one question which is related with TS diagram, that is the temperature versus entropy diagram. So you should not get confused with our previous slide diagram, where we have plotted temperature versus enthalpy, that is a TH diagram. But here we are going to study temperature versus entropy diagram. So you should understand what are the several lines drawn in this diagram. So we will just study this point in this slide. So in case of temperature versus entropy diagram, you can see we have taken temperature on y-axis and entropy on x-axis. So this is the TS diagram, in which we can see a bell-shaped curve which is represented by alphabets A, B, C, D, E. So if we look at this curve, then we can divide this entire curve into two parts. The first part of this curve, which starts from alphabet A, and from this alphabet A up to point E. So this entire curve, we call it as saturated liquid line, whereas the remaining part of this curve, starting from E and ending with H, we call it as saturated vapor line. So in simple words, the bell-shaped curve consists of two lines. The first line we call it as saturated liquid line, and the other one we call it as saturated vapor line. So the point E, where these two lines meet each other, we call it as critical point. At the critical point, the pressure is about 221.2 bar, and temperature is about 647.31 Kelvin. Now again, on the left hand side of this saturated liquid line, there is a liquid region which is shown as capital L in this diagram, whereas on the right hand side of saturated vapor line, that region we call it as a vapor region, which is indicated by a capital V in the diagram. Again, the horizontal lines which we can see in this diagram, those are nothing but the isothermal process or the constant temperature lines, whereas the vertical lines are the constant entropy lines, or we can call it as isentropic process. Here we can see certain notations that are used, that is SF, which is nothing but it is the entropy of liquid. Again we can see SFG, this is nothing but the entropy of evaporation. Again we are having SG, it is nothing but the entropy of vapor. So these were the notations for entropy. If we consider the area under this curve, where we can see that they have represented this region as L plus V, so we call it as wet region. That is nothing but it is a mixture of liquid plus vapor. So this was all about the temperature entropy diagram. In MSBT paper, this question can be asked for 4 marks, out of which 2 marks will be allotted for this diagram, and the remaining 2 marks will be given if you are able to explain what this diagram consists of. So with this point we will stop here today, and in the next lecture we will continue with the further points from this chapter. So till then, thank you very much.